All right, so we're doing transformations of two main ones, two doing square roots and cubes, and then there's a kind of a minor one that will spin off of this one. Remember, square roots will look something like that. When we're talking about cubes, then we're talking about x to the third. Today is the 15th, and again, if you're keeping up with the notes, this is number 12 on the list. Okay, so when we're talking about square roots, we'll go back to kind of like we were doing yesterday. That just like yesterday when we were doing absolute values and other things, we started off yesterday with we had x minus h squared, and then we said, all right, we're going to change that to so it's just the absolute value of x minus h. When we're doing this one today, it's basically the same thing. With square roots, we normally would start off with square root of x. The basic shape when we're talking about it will look something like that. Now, and with the a, it's yesterday we how a talked about we said it was the direction on this one. A is still going to be the same thing. The a part of it still tells you the direction. Positive is up, negative is down, so that part of it's still going to be the same thing on this one. And then the h and the k, it's not necessarily that it's a vertex, it's more of it's a starting point. So with the other two graphs we were doing, it was the vertex. Today with square roots, it's more starting point because there's not an actual vertex on this one when we're going through everything. All right, so if we start with just the plain, basic, easy square root of x, we're going to show you that graph and just kind of get you the basics of it here. And this part of it, you don't have to write this part down over here, but just to kind of give you an idea of what the numbers would be. If we plug in 0, the square root of 0 would be 0. If we did the square root of 1, that would be 1. So when we're plotting this one, we start at 0, 0. Our next point would be at 1, 1. Okay, now if we did square root of 2, square root of 2, we don't know what that is. It's about 1.4, so we're not really even going to worry about that one, so you wouldn't have to worry about that one. Basically, we're just going to stick to the perfect square roots. The next perfect square root we have would be square root of 4. If we did the square root of 4, that would be 2. All right, so that would put us like here. And if we start connecting the dots, it's going to look something kind of like that. All right, so if you do just the basic square root on this one, it's going to look something kind of like this. Okay, and then what we're going to do is we're just going to give you some of these to kind of graph and look at some different things on this one, and just see what it is that we're going to do with the different parts of it here. And again, you're going to be picking multiple choice graphs on these, so you're not going to get super complicated on this one. And you may be asking, all right, what happens when we get below 0? Well, what happens if you take the square root of negative 4? Anybody remember what we were doing a little while back with negative numbers? What do we have to? What's different about the square root of 4 versus the square root of negative 4? What's the difference in the answers on those? All right, you got to use the imaginary number, right? So if we do the square root of negative 4, that would be 2i. There is no way you can plot 2i on just a regular number line. So that's why when you get to anything negative, we stop right here. There's nothing else you can do back here negative wise because you can't plot 2i because it doesn't make any sense here. So anytime you get a negative number, there's nothing you can do on that one. We're not going to do anything here negative wise because there's nothing you can do to plot those. So that's why it's basically like half a graph. You got to stay so that it's above 0 for this thing. The one thing that we will kind of add with this one when we're talking about with square roots, it's going to talk about domain. And when we talk about domain, you're basically going to do one thing for this one. You're going to set the inside of the square root greater than or equal to 0, and then you just solve. Okay, and we'll do that on some other problems because this one, if we were doing this problem, there basically for this problem, we can kind of go ahead and do it here. If we were doing domain on this problem, you would take just x greater than or equal to 0, and there's no solving on that one because you've already got the x by itself. So that one would be it. All right, if you talk about the range, it's kind of a two-part thing on this one. There's like an A and a B here. That if A is positive, you set y greater than or equal to k. And then for the B part is that if A is negative, because again, that's the direction part of it, and it's either positive or negative. So if A is positive, y is going to be greater than or equal to k. If y is negative, y is going to be less than or equal to the k value. Now, and you won't see that on a lot of questions, but they'll mix in a question or two here and there where it may talk about domain and range. So if you see them talk about domain and range in this case, that's what you're going to do. And again, for this problem back here, the h and the k values would both be 0 because there's nothing back here. So if you had to talk about the range on this one, the a value would still be 1, so it's positive. So the range in this case would be y greater than or equal to 0. Okay, so there's the basics on everything that we're looking at. And we'll kind of get through the rest of it here. Okay, so let's give you some examples where we have to go back and graph a few questions and just see what you can kind of do with it here. Okay. All right, so let's graph y is equal to square root of x minus 3 plus 2. All right, so first thing is, again, you got your h and your k here for those two numbers. So that basically means this would be, and you can do it a couple of different ways. You can think about, that this would be 3, 2 for your starting point. They may also ask you, what does this 3 mean? This means you're moving 3 spaces to the right. And then the plus 2 means you're doing 2 spaces up. So they may ask you one of those two things, either option on that. They may ask for the h and k values, or may say, all right, what does that mean with these two values here? Okay, so we'll go 3 right, 2 up. Put your starting point there. And then again, it's going to always just have that kind of a run off to the right side of it there. All right, and we'll talk about domain and range here just in case. Because again, it's 50-50. Sometimes they will ask about it, sometimes they won't. Sometimes they'll just let you graph it and be done with it there. All right, so for domain, you just take whatever's on the inside greater than or equal to 0. And in that case, you would just add 3 to both sides, so then your x is just greater than or equal to 3. All right, in your range, that's just your k value here. It's going up, so we need to go y greater than or equal to, and just tell me the number that's there, so that'd be y greater than or equal to 2. So domain will always deal with what's on the inside. The range will deal with what's on the outside there. Okay. I'll hang on before we do that. One other little thing to kind of go with this one. If the absolute value of A is greater than 1, now they'll talk about it later with some other examples that we'll talk about, and they don't really kind of mention it with this one so much, but it's kind of when you're graphing some of these, what does it say the graph will be steeper? So if you have a value, if you do the absolute value of A, and it's bigger than 1, the graph will be steeper than if you were just doing like a regular normal absolute value or square root of x for this one. And if that A value happens to be somewhere between 0 and 1, if it's like 2/3 or half or something like that, then your graph will be flatter. Or less steep, or however how you want to say it there, then y equals the square root of x. Okay, because some of these they're going to have you do, besides just like a normal graph, they'll put some value in front of it. And it's not a huge deal depending on the number, but it just kind of should give you some picture of exactly what it is that they're going to look at for one like this. All right, so if you were to graph this one, because we're not going to worry about the main range here, we're just going to graph this thing. The -4 on it, because if you kind of pull out your h and your k values for your starting point, that would be at 0 and then -4 for your starting point. Because there's nothing on the inside with the x, we've got the -4 on the outside, so that puts our starting point at 0 and -4. All right, so we'll start that one there. Okay, and normally we'd kind of, if we were just doing square root of, and we'll kind of do like 3 here. If we were doing square root of x, it would look something like, I do it with a dash line here. If we were just doing square root of x, it would be something like that. Because it's 2 times the square root of x, it's going to be a little bit steeper. So it's going to take off and do something kind of like that. Okay, just like if we'd taken the 2 square root of x we had here, if we made that 12 square root of x, then this thing's going to be a whole lot steeper. It's going to go up something like that. So the bigger the number, the steeper the climb is that's going to be. The smaller the number, then the flatter it's going to be. Okay, not that we had 12 square root of x there, but if we had, it would look something kind of like that. All right, and at the same time, example 3, we'll kind of do it just right underneath here so you can kind of see what it would be. For that one, we'll do like y is equal to a half, or let's do a third of x, -4. So it's still at the same starting point. It's still at 0, -4. But if we do 1/3 of x, well, that's going to make it come off a little bit flatter. It'll look something more like that. Okay, so if it was just square root of x minus 4, that would kind of be the dashed line we were talking about here. And again, if they put a number in front that's bigger than 1 when we're doing the absolute value of it, it's going to be steeper. It's going to go up a little faster. If that number happens to be smaller than 1, if it's a half or a third or two-fifths or something like that, then it's going to be a flatter curve when it comes off of it. All right, in example 4, we didn't really look at one like this. We'll make sure we get one with a negative here. Let's do -2 times the square root of x plus 3. All right, and again, the plus 3 means if we're looking for a starting point, that'd be -3, 0. Just got to back this thing up 3 spaces and start it over here. All right, and the big difference is with that a value being -2, instead of going, if it was +2, we're going up, but because it's -2, we're going to go down. Do something like that. Okay, so that's pretty much about it. All right, we'll do domain and range on this one real quick. So domain here would be x plus 3 greater than or equal to 0. We'll just subtract 3 from both sides. So your domain would be x greater than or equal to -3. And for the range, because it's negative, we're going to go less than. It's going to be y less than or equal to whatever the y value would be, which in this case was 0 from the starting point. So it's just going to stay y less than or equal to 0. Okay, so square roots, for the most part, pretty straightforward. It's basically half a graph because, again, if you throw in a negative number inside the square roots, it's not a real number, it's imaginary number, so we've got to get rid of that part of it. And then everything else is, again, if it's negative, you're going down. If it's positive, then you go up, and it's always kind of just it's like half of a quadratic. If we were to take this thing and finish this thing out this way, it's like half of a quadratic turned sideways, if you want to kind of think about it there. Okay. Last thing, and actually there's one, I caught something in the homework, something that snuck in there that I wasn't able to change because somebody had already kind of taken a look at these. But the main big thing we've got here, the last one here, the last half of what we're going to do is we're going to do x cubed. And we'll give you the basic part up here, and then we'll come back and look at the standard form of it. X cubed it looks a lot like x squared. It's going to come in like x squared would have done. We get down to 0 and have a turn here. The big difference is with x cubed, though, is that if you do a negative times a negative times a negative, the answer stays negative. Where when this was x squared, we'd make it turn and come back up. By being x cubed, you can't get negative answers. So now this thing is going to turn and go and do something like that. Okay. And again, that's kind of the big difference. If we were doing x squared would have turned and gone up this way. But x cubed, these numbers actually they will be negative, because if you do a negative number 3 times, it makes a negative. So instead of turning up, now it's going to turn down and kind of come that direction. Okay, so when we're doing this graph, when we're talking about the different things here, going back to the A value like we were doing a minute ago, if you do the absolute value of A, if that is greater than 1, then they call this thing being a stretch. And it's kind of like we were saying earlier, that it's going to make this thing go steeper. And if you think about that being like a line, if it's kind of loose, and then you grab the line and you start to stretch it out, this line is going to get tighter. It's going to go more this way and more this way. So if your A value is greater than 1, if you do the absolute value of it, it's going to make this thing stretch out, and it's going to make this thing get tighter, because you can think about it like having a loose line that's here with a pivot point in the middle. And then if you start to stretch this thing out, then this line is going to get tighter this way. All right. If that absolute value of that A value is somewhere between 0 and 1, if it's a half or a third or a fourth or something like that, then you're loosening up the line. So you're going to compress, or you're going to shrink the graph. Okay, now the H and the K, it still works the same way. You take the H, that's your horizontal movement. The K is still your vertical movement. Now in this case, though, it's not a vertex. It's not a fill in the blank, whatever you want to call it. It's more of just it's like a pivot point. So in this case, H and K is not really the vertex. It's more of a, and I don't know if that's a correct mathematical term, but we'll just say it's like a pivot point. That's your focus point, or whatever you want to call it. That's kind of the main thing that you're looking for here. So it's not really a vertex, but it's still an important point. And again, pivot point's not exactly it's not a mathematical term. That's just kind of me saying, hey, it's important, but it's not the vertex, but it's still kind of good to have that number for what we're looking for. The main thing is that H is still going to be your horizontal, and K is still going to be your vertical when it comes off of this thing. So it's going to be a horizontal translation, and then K is your vertical translation. So same thing we've been doing, no difference on that one. Again, the H will always be in the opposite direction. Okay, so nothing different on those when we go through everything. The one other thing that they do with this one, if A is negative, then we'll say that causes a reflection across the x-axis. Okay, that before it was a positive or negative type thing. This one, it's half positive and it's half negative. So in this case, they're saying, all right, well, since we can't just say that it's going to make that kind of thing with here. So it's still, if A is negative, it's going to be a reflection across the x-axis. And I think we talked about that even when we were doing quadratics way back when. This one is just a little bit harder to see because it's already half positive and half negative. Quadratics are a little bit easier because it's either all positive or it's all negative when it comes off of it. All right, now what they're going to have you do on these, probably more than anything else, they may make you graph some of these, but some of these they may make you pull out some word problems. But we'll go ahead and do a little bit of both here. So let's say we've got a graph, y equals x plus 1 cubed minus 4. And we might actually do 2 problems here. We'll see. Okay, so if we want to, and again, it's not the vertex anymore. It's just an important point. I don't know if it's an inflection point or a pivot point, but basically, it's just an important point that you need here. So we'll need to go to -1, -1, 2, 3, 4, and put a dot here. And that's where everything's going to kind of spin off of this thing. So go to -1, -4, put a dot here. And again, the graph is going to kind of come in and turn here. And instead of turning and coming back up, now it's just going to turn and then head back down. Okay. They won't ask you about domain and range because domain is all real numbers because you're going forever to the left, you're going forever to the right side. The range, it's also going to be infinity because you're going forever down and you're going forever up. So domain and range in this case are both going to be infinities. So they probably won't ask you about domain and range because it's always going to be negative infinity to infinity when you go through this one. Okay, and again, as long as you got kind of an S-shaped curve on this one, they'll be pretty easy to pick out for the multiple choice on these when you're doing those. Now, they may ask you a word problem on this one. It may give you a word problem that's something like this, where they may not ask you to graph it. If we need to, we'll graph it in a minute, but if not, let me do this. If this thing had been negative, it would have been the exact same graph, but you just spin it upside down and then go from there. But most of these, they probably won't make you do some of that. They'll probably just leave it like this when we're going through these. All right. Here's kind of a word problem that they'll give to you. And it's not a hard word problem. It's just one that they'll throw at you here. They may do something like this where they'll say, find the equation of y equals x cubed. With a stretch of 4. A reflection across the x-axis. A vertical translation three units up and a horizontal translation two units right. All right, the good news is you'll be given that one, so it won't take you, the time to write it down. They'll say, okay, here's the question that you have, and then they're going to say, just tell me what the equation is. Don't worry about graphing this one. Just tell me what the equation is so that you know what everything means. Okay, the first thing is you've got a stretch of 4, so that's your A value. So that's kind of what we're looking for. Again, you got to find out what your A value is. You got to find the H value and the K value. And basically, we're kind of figuring out what all those things are in here. So the stretch of 4, that's your A value. That's going to go in front. The reflection across the x-axis, that makes that a negative. The vertical translation, that's the up or down, that goes on the outside. So it's up, so that's a +3. And then the horizontal translation, that's a 2. And again, it's always the opposite sign. If you go to the right side, those numbers are usually positive, but we got to do the opposite of that. So we got to make it a minus. Okay, so long problem to write down, easy problem to write the answer for, because it's going to be, just figuring out what the pieces of it's going to be. All right, now, and one problem that kind of snuck in on the homework, I didn't mean for it to, but it was already there, and I could not take it out without getting everything all messed up. There was a problem that snuck in with cube root of x. And it's basically the same setup as what we're doing up here for the x cubed, but it's just It's going to be that. When we were doing x cubed, we had this. So if it's cube root of x, it's this one. It's the exact same graph. All the rules are same. Everything's exactly the same setup. So it's the same as x cubed, except the graph is more horizontal than vertical. Okay, and there was just one of these that snuck in. So again, I think it was one of those, just kind of looking at it real quick. I saw the third and thought it was a cube problem, but it wasn't. It was a cube root problem. But again, it's still it's the exact same setup. Everything's the same. And let's just kind of show it to you here. That if we were going to graph this one, if we were doing x to the third, we were just saying a minute ago that x to the third looks something like this. Okay, if we were doing the cube root of x, it's the exact same graph, but instead of, you still start here at 0, 0. Instead of going kind of up, this is one where you kind of go off to the right this way. And instead of going down, you go more to the left. So it's more like that. So where x to the third is a vertical graph, the third root of x, or the cube root of x, it's more of a horizontal graph. But they still cross over that pivot point, whatever you want to call it there. It still starts at 0, 0. The movement's still the same. If it's minus the h, this is still kind of like your pivot point. You're still going to move this number left and right. You're still going to move this number up and down to kind of get the graph of what you're doing there. The a value would still be a reflection if it's negative. Everything about it is exactly the same setup. It's just now you're going to use this graph instead of this graph. Okay, and again, that was my bad. I had one that kind of snuck in on us there, and I didn't really mean for it to work out that way, but it just kind of did. But there's only one. I just had one little mistake on that one. All right, and then the last thing we have, one word problem. Show you the setup on that, and then we'll wrap this thing up and be done. And this one is one of those where you just kind of watch, because it's a different setup. Because this one, they're not going to ask you to graph it. This is one they're going to ask you to solve a word problem, but it's going to be kind of spinning off of what we're doing here to kind of make it work out. So. All right, so here's the big word problem. And again, this is the last one today. The distance d that an object falls is directly proportional to the square of time, which they're going to call t, that it is in free fall. Okay, I'm going to kind of break this up into like three parts of it. And they're not going to have bullets out beside it, but we're going to have like three sentences here. So we can kind of see it. It says an object in free fall for 7 seconds has fallen 784 feet. And then they're going to say determine the distance fallen in 3 seconds. All right, we'll give everybody a second to kind of digest that one and see what's going on here. All right, so what we're going to do is we're going to take it one sentence at a time. So the first sentence is basically step one. And for that one, that's just setting up the equation. Okay, so they said the distance d that an object falls is directly proportional to. That basically means it's equal to. All right, now I'm going to ask a really easy question. When you drop something, what's an impact? What causes something to fall? Gravity, right? Gravity's got a force to it. It's got a thing that it has. So they say, all right, so to figure out what that is and how the gravity is impacting it, we're going to call that K, and it's a constant. Why they wouldn't call that C, I don't know. But they call it K. I guess the language it came from, maybe it was K there. But anyway. All right, and it says it's directly proportional to, so there's our gravity. That's the impact on here. It's the time t squared. So then it's t squared. So that's the equation we've got to get it set up. So the first sentence is the step one part that's telling you, all right, what's it doing, what's the variable is going to be. You'll always have this K that's here because you've got some impact if it's, if you're doing mass equals, or acceleration equals the mass and acceleration, the whole velocity type thing, you got a formula there. If you're talking about the price per gallon, then that's your constant that you have. So you always got some constant, some number you've got to deal with. Okay, your second sentence is telling you what numbers to plug in. Okay, so your second sentence that we've got here is telling us, all right, you got to plug in these numbers. So it says the 7 seconds, that's our time. So we're going to plug in 7 for time. And the distance is 784. So that leaves us with the K and then the square here. And then you basically just work this thing out. So you've got 784 is equal to K times 49. And then after you plug in your numbers, well, then you solve it. Well, you've got 784 is equal to K times 49. You're going to divide both sides by 49. And if we do that, we figure out that the K is going to equal 16. Okay, but we've still got one more sentence. So that's the first two sentences gone. So the first sentence, that's setting up the equation. The second sentence, you plug in the numbers they give to you, and you solve for the variable, whatever you got left over, whether it's, most of the, and again, the K is just any constant you're going to use anytime for whatever it's going to be. Well, we've got one more sentence. So then the third step, you plug in your values again. Basically, now you've got new numbers to plug in, so we're going to plug those in. So back here in step 3, in that third sentence, we've got that the distance fallen is 3 seconds. So our time was equal to 3. And then what you're going to do then is that we're going to use this new value also in this sentence, that we're also going to use K is equal to 16. And we're going to plug that back into that equation from step 1. So D was equal to KT squared. Well, then you just plug in these two new numbers we've got now over here. So K was 16 and the T was 3. And then from there, it's just order of operations. 3 squared is 9. And if we do 16 times 9, that would be 144. And it said find it, how many feet it's fallen. Well, that'd be 144 feet. Okay, so and all those word problems are going to be very similar to that you'll have basically 3 sentences. The first sentence will be the setup on the equation. The second sentence, you're going to plug in the numbers you have, and then in that case, you're always going to figure out what this K value that's going to be here. You got to figure out what the force is that's impacting it, whether it's gravity or whether it's the price per gallon or if it's the pressure that somebody's putting on an experiment that they're doing, or if it's you're blowing up a balloon and it's the force that's been exerted on the balloon, whatever it is, you've got to figure out what that constant is that's always pushing on this thing. And then that last sentence, that third sentence is, well, they're going to give you one number. And after you found this number, you're going to take those two numbers and plug it back into that equation that you have from step 1 to figure out what the problem is going to be. Okay, so that may be a little bit different, but they'll all be in that same setup of how you walk through those numbers to find out what the answer is going to be.